My name is Pavel Feldman, and I'm working on Chrome developer tools. I'm also an engineer working on WebKit Web Inspector. And I'm going to talk about Chrome developer tools today, but before I start, let me gather some stats from you. Who of you knows what Firebug is? Please raise your hands. Okay, so that's a lot. And who uses Firebug on the regular basis? Okay, almost everybody. What about Chrome developer tools? Who knows what it is? And it's a fair share. And who uses it on a regular basis? Okay. So one last question. What about WebKit Web Inspector? Have you heard about it? Okay, there's some. Okay, so Chrome developer tools is to Chrome what Firebug is to Firefox. So it's a set of tools that you're using for your web development. It has a number of perspectives. It is covering a number of capabilities for working with the DOM, for working with the network, for working with JavaScript, for debugging it, etc. Now, unlike Firebug, developer tools is a part of Chrome distribution, so you get it on any machine where you install Chrome. Okay, the Wave thing. The doc is a Chrome developer tools, and the Wave is where you can go and type in your questions. If we don't have time to cover those during the session, I'll try to answer them offline. Besides, we'll have another session dedicated to Chrome developer tools later today at 3 p.m. and I'll try to cover those questions there. So the developer tools, part of a standard Chrome distribution. It is heavily based on WebKit's Web Inspector, and you can see Web Inspector running in any instance of Safari. So essentially, it's a single source. It's unique in some way because it is based on a Chrome's V8 engine, JavaScript engine that is different for Chrome, a very powerful and fast one. It is also using, it is also a part of a Chrome multi-process architecture. So unlike classical WebKit, Web Inspector, we're running out of process. Now, I'll talk a bit about the project history today. We'll make an overview for Chrome developer tools, and I'll go through all of the panels, and I'll show you the basic capabilities that are there. And then we'll go through a number of user stories that I'm sure you'll find interesting and familiar. We'll be talking about debugging JavaScript. We'll be talking about making your web applications faster. And we'll also be talking about making your applications consume less memory and fight memory leaks. Now the history. The first version of Chrome had a rudimentary support for developer tools. We only covered elements for DOM and resources for network, and a limited console capability so that you could evaluate expressions on the fly and debug them. And that was all in process. That was all a rudimentary support as a part of WebKit rendering engine. And we didn't really do much effort to make it work in Chrome. Now with Chrome 2 is not even mentioned here. And somewhere in between Chrome 2 and Chrome 3, my team started working on it in St. Petersburg, and we've made a bit of a progress there. First of all, we re-implemented the entire Web Inspector infrastructure to allow the out-of-process operation. Then we made it work with the V8 engine, and for V3 we have introduced graphical debugger and the CPU profiler. And I will be talking about those in greater detail, just giving you a timeline here. Now with Chrome version 4, we started adding stuff. So we've covered the feature parity with WebKit via the storage panel, and then we have introduced timeline and the heap profiler. Both are going to be covered in the talk. And the last thing that we have added in the Chrome 5, and it's not beat anymore, it's the audits. Also going to be covered. Now the reason I'm listing all of these panels in each of the release is that we're not only adding new panels, we are improving every and each of them every time we make a new release. Now the overview. I won't have too much slides for you. It'll be all live demo. If you've seen my Google I/O talk, it'll be close to it. I still think you will find some things new and familiar. And with that, I'm just switching to the running Chromium instance. So that's Chrome running full screen, and I'm starting with bringing the developer tools by pressing Command-Option-I. It's Control-Shift-I on Windows and Linux. And that's the default view. You get developer tools docked in the window. Let me undock it to show you what it is about. Here it is. Now we're running developer tools undocked in a separate window. And I'll go through all of these panels one by one, and I'll tell you what they are for. Before I do that, again, it is all based on WebKit Inspector. We, Chromium engineers working on the developer tools are also WebKit committers and reviewers. So we are contributing our code upstream into WebKit to make it available to any WebKit-based browsers. So if you happen to have the browser that is WebKit-based with development capabilities enabled, you will have our functionality there. So the overview. Elements. Elements is the first panel that gets opened by default, and that's the DOM representation of your page. You can see the DOM tree to the left and the properties of a selected node to the right. Now you spend your time here when you're visually designing your application. You're tweaking it and editing. Now let me show you how it works. I can use ear keys or mouse to start editing stuff. So I can edit attributes. I can go through them. I can create placeholders for new attributes to add them here. I can also invoke context menu. And there are additional capabilities here. For instance, I can edit this HTML stuff, and you can add arbitrary tags here to modify your page on the fly. Now that's selected nodes, and I can traverse them here. For every and each of these selected nodes, I can see their properties to the right. Let's go through them. These are computed styles, metrics, properties, and event listeners. We'll go by one by one. So the computed style is a number of styles as rendering engine perceives your element. So that's how rendering engine is going to be painting your element on the screen. So if you see something going wrong, the first place you go to is this computed style. And if the property, some border or a background is set wrong there, you know where to start. And the computed style section is read-only. It's just an aggregation of the styles applicable to your element. Now the style section is where the styles applicable to your element reside, and you can edit those. Those include the element's style attribute. You could explicitly set the style, CSS style for any element. Then there is a number of matched rules that are matching selectors in the CSS files or inline styles tag that are matching to your node. And then there are inherited styles, and we also support pseudo-element styles such as before and after, and placeholder, etc. Now these ones are actually editable. So you can double-click on that to start editing, and you can use Tab and Shift-Tab to traverse through them. The interesting thing here is that you can even edit selectors to make your style applicable to new types of elements. Well, this is a google.com page, so all the style sheets are in line. If they are not, you can navigate to those using the links to the right, and you go straight to the CSS file that you are defined. In addition to editing, you can toggle those, and you can create new style rules. So that's about styles. And we go further to the metrics. And metrics is an information about the box model of an element. And you can see all the paddings and borders and the size of the elements. You can edit it from here. Also using mouse, double-click it, and just edit it in place. Now the properties. All the DOM elements have JavaScript wrappers around them when you're talking to them from the JavaScript code. Like when you're typing document get element by ID, the thing that is returned to you is a JavaScript object that represents your node. But in fact, that's an usual JavaScript object, and you can set arbitrary properties on that. And the way you explore these properties is using the properties section here. You just select the node to the left, and you see all the JavaScript properties that are available on that node. We also draw a nice prototype chain of the elements so that you can see that the DOM elements, DOM wrappers, also form a hierarchy here. So there's an object, then node, and inherited element, then it is HTML element, etc. Those are editable, so you can edit values here, and they will be pushed into the JavaScript engine. And the event listener is something that is easier to show in an example. I'm docking the developer tools window back, and I'm using an inspect element tool to inspect a search field. And I can see that the search field has 3 types of event listeners registered to it. There are a couple of blur listeners. There is a key down listener and a key up listener. So let's look at those. I'm undocking it. So I can see the type of a listener. I can see the function body. I can even see the node where it is registered. I can jump to the source with a definition. Well, Google.com is minified, so no useful information here. But when you're debugging your code, you're working with the sources, not unminified code, unless you deployed it. So you have useful information there. Now, the interesting thing about this section is that the listeners are sorted in a capturing and bubbling order, so that the runtime is going to go through them in the same exact sequence. So they could debug it here and get a clue on what's going on. So that's basically what you see when you're opening the Elements panel. The important thing is that there is a console. That is a very handy tool, and you should use it in combination with the Elements panel. We do support something that is called command line API that has been defined by Firebug, and it has some cool features such as referencing a currently selected element using $0 or previously selected element using $1. You can also dump elements in their JavaScript representation, or just dump in DOM node. So a lot of stuff is available here. You can even make a command to the developer tools itself to show the previously selected node, and it'll navigate there. Or you could start monitoring events or DOM events based on some particular node. So if you don't know what command line API is, I encourage you to go and look at it, because it is a very powerful set of commands, set of tools that you should be familiar with. So that's the Elements panel. Again, you're designing your web application, you're tweaking it here, you're changing styles a lot in line using this panel. The next one to talk about is resources, and for that, let me navigate to Gmail. So let's see what's happening here. Now, the resources panel is the one that you are spending your time dealing with network. All the network resources issued against the servers are registered here, and we've got some information on these records. Let us explore what Gmail does when you're loading a page. So first, we went to gmail.com. And we've got HTTP headers here that tell us that it actually has been redirected. We've been moved permanently using a status code 301. And it tells us that we have redirected to mail.google.com/mail. Let's continue. So that's the mail request. It also is a redirect. And the reason for that is that I don't have cookies for signing into my account, so I was redirected to the service login page. Let me go to that one. And the service login page is the first one to be served with the real content. So that's the HTML that has been served from the server. It also has headers, and the headers here are saying status code is 200 OK, and those are the headers. Now, we've got a nice preview for the content of the file here. And we support these previews for JavaScript with nice highlighting, and for images, and for web fonts, and etc. Going back to the timeline. So that's where we started, and that's the time perspective to our network load. We can see that there have been 2 redirects followed with a successful load. The semi-transparent part of a bar is a latency we've been waiting from server to respond, and the solid part is the time that took server to transmit the data. And the blue line here is when the DOM content was available to the JavaScript. And the red one is when onload event has happened. So you must know that if you want something to happen when the page is loaded, you make an onload event handler. Now, we can see that it took us 1 second to go through the redirects and to get the page loaded and visually available to the user. There is also a size perspective, and you can use it to get a clue on what is the size of a resource. And we support 2 types of sizes. First is the size of the actual size of a resource, and the other one is the size of resource transmitted over the network. And the reason these are different is that most servers are using gzip encoding, so that the transmitted size is going to be, what, twice less in this case. So that's the resources panel. There's also a sorting algorithms that we could use both in time and for the size. There are filters, but overall it's a very simple panel. Still very useful when you're dealing with a network. Now, the next one to talk about is scripts. And scripts is for debugging. And I have a dedicated story about debugging for you now. And I'm skipping this one. And I'm also skipping timeline and profiles. Going straight to storage. Storage is a panel where your offline content is being inspected. And that applies to cookies, local session storage, and databases. Cookies are deletable. That's not editable yet. That's not a document cookies request that you get inside the web page. This is a real representation of the cookie store within Chrome browser. It has HTTP and secure cookies flags here available. Now, local store and session store, won't be talking much about it. It's just that you get a table, an editable table, where you could use and edit those HTML5 storages. Databases, let me show you it real quick. There's an HTML5 demo called Sticky Notes, and it's based on the HTML5, fairly old one. So I can click on a table and see, actually click on a database, see the number of tables here, dump their values, issue SQL requests, and you can see a nice code suggest here, suggesting me what I should type. Error support, whatever, so we get a decent SQL console here, working with HTML5. Audits, something that we have recently added. It's a number of sanity checks against your page that gives you advices about what to do to your page to make it load fast, or to make it more compatible, or to utilize network better. So let me run it against google.com, and I get a number of hints that I should have used better caching policies that I've been, that google.com doesn't have a cache, but we want that. That I should have minimized my cookie sizes for accessing static resources and such. And I even have CSS rules that are not used on the load time, and the reason for that is that they are dynamic, and that's the menus appearing in the Google when you're hovering over elements now. Now, going back to the product. The console is the last one, but a very powerful one. You can do JavaScript computations here. You can dump objects, as I've shown, and there is a nice code suggest here. A very powerful tool. You can use it at any time of your project runtime to see what's wrong there. So that's kind of the overall functionality, available pretty much in all the WebKit-based browsers. But I have something different for you today, and that's these 3 stories that I'd like to run through. And the first is debugging. And I'm keeping the demo open. We'll be debugging a web application that is called HoverCard. Let me dock developer tools. So the application is a part of a closure library that is providing a cross-browser rich HTML hover cards, tooltips, basically, for the elements. So I hover over an element, and the tooltip appears. Now let's debug and see how this works. I go to the Scripts tab, and I happen to know that the hover card uses a lot of files, a lot of utilities within the closure library, but the major functionality is residing in the hovercard.js. So I click the file selector, and I chose the hovercard.js file, hit the enter. Now I also happen to know that the interesting code within this file is around line 200. So let me set a breakpoint there. I hover over an element and I hit a breakpoint. Let me undock a window. So what we can see here is the scripts panel being oriented to debugging JavaScript. So we've got a lot of real estate dedicated to the scripts. You can select scripts here, choose them, see them, traverse through. Now we are currently on a breakpoint, and what we can see on a breakpoint in any IDE is the stack trace. So there's a stack to the right. You can select elements here, the call frames, and see where in code they are located. Now you can hover over elements and see their actual data while on a breakpoint. And if it is an object, you can explore it. If it is a string, you can see a snippet for it. If it is a namespace, it's still an object, so you can explore it. So that's what you can see on a breakpoint. You can step through things. You can see local variables available in this stack frame. You can also open a console and use a code suggest to dump those values while on a breakpoint. So that's the exact state of your object while on a breakpoint. Now I'm releasing a breakpoint here. That's all pretty standard, and most of the IDEs and debuggers support that. But we have something in addition to that. Now imagine that you're developing a large app, let's say Gmail, and you know there's a bug. But the bug only shows itself when you're opening and closing a few emails, and then you're opening a special page, go to settings, enable something, and then, boom, it triggers. Now, when you're fixing it, you need to apply a fix. You close the app, you deploy the files, you reload the app, log in, read several emails, go to settings, change something, and hope that it reproduces. And then you check whether you have fixed it or not. But it would be really great to skip all of that hassle and do it right in place. And that's actually what we now support. So we can now edit function bodies live. Let me show that to you. I'm double-clicking a line here, and I got a cursor in editable text here. So I'm reverting the condition. And let's see if the app is working. Well, it's not working anymore. Okay. So what if I do something else? What if I add console logging here? I'll be dumping the optional position value here. And let me actually fix the code so that it's worked again. Okay. So the app is working again. I can see nice hover cards. Let us look at the console. And the console is now printing the optional parameter values. Well, they are all undefined in our case, but you can see that as I move my mouse, they are being dumped. Now I can press the double-click the code again, comment it out, and it'll get highlighted as commented out. And the app will still work, but the console is now empty. Now, it was actually pretty tricky to do that, and the reason for that is that V8, our JavaScript engine, is compiling code. So we are not interpreting it. We can't just change the text and make it work the new way. We needed to recompile JavaScript source code into a machine code, then patch these machine code instructions in the memory, and make all the objects reference the new function body since then. And it even works while you're in a breakpoint. Let me hit a breakpoint, go somewhere, and I'll just play the same trick again. But when I am committing, I can't continue execution of a machine code that has changed on the fly. So I'm getting back in time into the time prior to calling into the modified function. So if I enter it again, I'll enter the newly modified function. So that's something that is unique to Chrome Developer Tools, and that's something we are very excited about, and we are planning to explore that further. Now, the other thing that I wanted to show you is identifying performance. Now, imagine that your app is now working properly. You fixed all the bugs. It's perfect. It is slow, though, and we know that speed is important, so you start tuning your application. We have profilers for you there. And let me go to a different site that is using Canvas to render a DNA at a runtime. And I'm opening the Profiles tab, and I'll start recording. Now, while I am speaking, developer tools are capturing the state of JavaScript stack on a ratio of, on the frequency of 1,000 times per second, and it is aggregating this information. And when I have collected enough data, I stop recording, and let's explore what has actually been happening in this Canvas TNA demo. I switch to the top-down view, where I start with the entry point into my JavaScript application, and I start exploring. So I know that 80% of time was spent on the animate, and it was calling render, and it was doing lines and such. I can click on an element to see where it leads to see the body of the function. I can even look at the I can even look at the performance of the native functions. Look at these set, stroke style, and stroke methods. They don't have corresponding JavaScript lines. That's because they are native. They are native functions on the Canvas object, but they are still taking time. That's because we are calling them too often. Now we can see that they are taking milliseconds of time. And if I switch to the heavy view, I will see those being on top. So the good advice for this application would be to optimize calls to the stroke style setter. It's even cooler. It's not a function. It was a setter that resulted in some computation. Now, that's what we use for profiling JavaScript. It is nice. It is sampling based. It is being run from the different thread so that it is not affecting your web app performance. It's not an instrumentation that is adding counters into your functions and hence affecting the way things are doing. But JavaScript is not everything within your app. There are native parts of code that are spending time. And interesting ones are rendering, calculating CSS styles, issuing network requests. They are all taking time. And we can address that. We're using a timeline panel for that. Let me go to the google.com search results for a second. And let me start recording and reload the page results. So that's the timeline panel. It has an overview on the top with types of events we are capturing. They are not necessarily JavaScript, they could be native. And you can see the log of everything that has happened at the bottom. Now for every record you have details, and we can explore a part of the execution that has happened here on the google.com results page. I can see that there is a script that has actually caused a lot of style recalculations. So script was doing something to part of DOM iteratively that resulted in continuous style recalculations. And this thing was taking time not within JavaScript, but within native code, within browser. But you could optimize it. You could remove a fragment from the DOM, mutate it, and stick it back so that the recalculation, then reflow, would happen only once. And now you have a good clue on how to do that and where it makes sense for you to do that. So the timeline we were doing for performance, for native performance, we added a lot of instrumentation into web core that is reporting the information back. But we learned that it is a great tool for exploring your code too. And let me actually show it to you. I'm using a Zippy code, and a Zippy is another sample on the closure library. You can expand and collapse compartments in a browser-independent manner. So let me actually record what's happening when I'm doing that. Okay. So I started recording, I've done something, and I stopped recording. Let's zoom into the area of interest. Now I can see an event here. An event took 0 milliseconds, so it did pretty much nothing. But let's try expanding this bar. Oh, so there has been something. And this something has been executed asynchronously and caused by an event. Now let's explore events here. We've installed a timer in register animation method. Then this timer fired and called cycle animations. And the timer has been installed for, what, 20 milliseconds. Now, the cycle animation was called, and the first line it does, it removes the timer. But in the very last line of the same method, it installs it back. So what's happening is a timer-based animation where you're using the same timer recursively to reschedule itself and do the smooth transition of the compartment. Let's see what it ended up with. And it ended up with removing the timer in the unregistered animation call. So this thing is pretty unique. And the reason it is unique is that it captures the control flow of your web application, a JAX web application, in a synchronous manner. So all of these calls were done based on events, asynchronous, but we can still see that the root cause of all of this was a single event here. I can filter out less important events, and I will see a single entry that took time on my application. I can see the cause and implication for all of the actions. So that's the timeline story and performance story. And the last topic is memory. Now, we have our application working properly. Good. We now have it working fast, even better. Now imagine that you leave your application overnight. If it leaks memory, it'll be lagging in the morning. And that's what should not happen. For that, we have a memory profiler, and it is very easy to show how it is working. I'm going back. I'll use the hovercard demo that we used in the beginning. Let me dock tools back, clear the console, go to profiles, and take a snapshot of the heap of the app. But before I explain what it means, let me move my mouse around and take another snapshot. Okay, I'm undocking the tools. Now what you can see here is aggregated information about the memory of your browser, about JavaScript virtual machine, its objects, their sizes and counts of elements. Now we can see that there is a lot of code, there are a lot of objects, there are some closures, strings, etc. We've got the counts and sizes. But what is more important is that you can take a couple of snapshots and compare them to one another, to each other. Sort by difference in object counts, and we can see that there are 34 more div elements. Now let's try exploring what is under the div element. And under each element, you can see a number of elements that are retaining references to it. So these are the guys preventing this div element from being garbage collected. So there are references to them somewhere. Let's explore further. So there's an event listeners and handlers holding it. But there's also a console object holding reference to these div elements. Now there are 34 more guys being retained by div console. And the div console is this event log. So when we are adding records to this log, we are actually leaking memory because we are retaining references to them. And now we have a good clue on what's happening. Now imagine it has been happening on timer. Overnight, it would add up. So that's the memory story. And that's actually all of these three stories that I wanted to talk about. Now, before we go to questions, I wanted to mention that at 3 p.m. We're going to have an in-depth talk about Chrome Developer Tools, where I will tell you how the Developer Tools is implemented, talk about Chrome architecture a bit. I'll talk about how to contribute to Developer Tools, and I'm sure you find it interesting if you're web developers. And then we'll have an extended Q&A sessions where you will be able to issue feature requests or shout about some functionality that we have. I know. Yes, I started late. 2 more minutes for questions. With that, let us switch to questions. Yes, please. Okay, keyboard shortcuts. Keyboard shortcuts is I open the developer tools and I press question mark and I see the hints on the keyboard shortcuts. Okay, more questions, please? Okay, any tools for Flash? No tools for Flash so far. So you can see it as an object in the DOM tree. You can call these JavaScript methods, no dedicated tools for debugging Flash ActionScript. Okay. Okay, are there any command line options to start developer tools? No, you got it enabled by default. All you do is you're using a mouse to inspect element, or you're using menu to go to developer tools. Unfortunately, it's behind the screen, or you press shortcut command option I and you got it available. Sure.
How closely do you track the WebKit, like upstream?
Okay.
on the tools and what, how much did you guys contribute back to them?
Okay. So how much do we track WebKit? How much do we put upstream? How much is Chrome specific? I'll be talking about it in greater detail at 3 p.m. The short answer is pretty much everything we implement upstream as a part of WebKit. And WebKit is being updated several times a day. So Chrome is on the very top of WebKit. Yeah, please. Yes, if you go to the Chrome extensions page, against every extension there is a DevTools link. You press it, or you just enable developer tools, then you press inspect link, and developer tools will be brought up for the particular extension. More questions, please? Yes, so the event listeners, do we show all event bindings for inline event DOM0 event handlers on DOM, or is it something different? So the events listeners section that I've been showing is showing you all the handlers for a particular event, whether they are inline or added using the add event listener API. And if it is inline, you will be navigated to HTML5 with the inline definition.